Hello students, hope you all are doing good. So students, today we'll discuss about chapter number 4, that is separation of substances. And in this chapter we will learn why separation of substances is important, what are the different types of substances, and what are the different methods of separating the substances in a mixture. So we'll start with page number 34, and the first topic will be pure substances. So a pure substance is a substance that contains only one kind of material. Means in that only one type of a substance will be present, and because of that substance is known as a pure substance. For example, clean water, sugar and salt are examples of pure substances. Now each pure substance has fixed properties like the melting and boiling points. For example, the melting point of pure water is 0 degrees Celsius and the boiling point is 100 degrees Celsius at sea level. Now these values can be changed if some impurities are present in it. Hence we use these properties like the boiling point and the melting point are used to test the purity of water. Means if these two terms fluctuate, so it means that that water which you have taken for testing is not a pure water. Now we'll come to what is a mixed substance. Now a mixed substance can be usually called as a mixture because in a mixed substance two or more pure substances are simply mixed together. These substances may be present in any proportion. The different substances, now the in a mixture, the substances can be present in any proportion. The different substances present in a mixture are called its components. Now the different substances which are present in a mixture are called its components. The components do not combine with each other and can be separated. So in a mixture the components do not combine and these components can be separated. An example of a mixed substance will be a mixture of sugar which is sugar and water, and the sugar will be dissolved in water. A mixture can be a solid, liquid or gas. Now the mixtures can be solid, liquid or gas and it will be based on the components. Mixture can be of the following types like the solid and solid. If the composition is both having two components as solid, so the mixture will be solid and solid, solid and liquid, liquid and liquid, liquid and gas. So these four will be the portions where mixture can be of different types. The components of a mixture retain their properties. For example, a mixture of salt, sugar and water will be both salty and sweet. Means in a mixture all the substance will try to retain its properties, like the salt will give the salty taste, sugar will give the sweet taste, and water will be water only as water is tasteless. Now mixtures can be divided into homogeneous mixture and heterogeneous mixture. So first we will try to understand what is a homogeneous mixture. So in a homogeneous mixture, the components of a mixture are uniformly spread throughout the mixture. The components are uniformly spread throughout the mixture and each part of the mixture has the same properties. Now if we take a homogeneous mixture and take any portion from that mixture, we will find that each part of the mixture has the same properties. Means the whole mixture will be having all the same properties throughout the composition. Homogeneous mixtures are uniform in appearance and composition. They will be obviously uniform because it is termed as a homogeneous. That is, the different components can be seen separately. Means we can see that the two substances, 2, 3, any number substance can be seen separately. A homogeneous mixture usually involves a solid and a liquid is commonly referred to as a solution. And in a homogeneous mixture, usually one substance will be a solid and the other will be a liquid, and we commonly refer to these as a solution. For example, if we dissolve salt in water, we get a solution in which the salt and water molecules are spread evenly throughout the solution. So in this, salt and water will be spread evenly throughout the solution. If we take a portion of the solution, that portion will taste salty, as salt will have a uniform composition as it is a homogeneous mixture. So next will be heterogeneous mixture. In a heterogeneous mixture, the components are not spread uniformly. There will be no uniform composition present in these type of mixture. We can see the individual components separately. We can see them separately. For example, a mixture of iron fillings and sulfur is a heterogeneous mixture. For example, if we take a mixture of iron fillings and sulfur, that will be a heterogeneous mixture, means we can see the individual components separately. We will find more iron fillings at some places and fewer at other places, means there will be no spreading of the components uniformly. In some portion we will find that iron fillings are more, and in some portion we will find that the sulfur portion is more. Dusty air is also an example of heterogeneous mixture. So dusty air is also an example of a heterogeneous mixture, because there is no uniform spreading of all the substances or all the components. Now we'll come to next topic, that is separation of substances in a mixture. We'll see how separation of substances will be done. The mixture can be separated into their pure compounds. So this can be done by using a difference in property between the components. For example, let us take a mixture of iron fillings and sulfur. Iron, as we know, is attracted to magnets. So here we will see how to separate a mixture. For example, if we take a mixture of iron fillings and sulfur, so we know that irons are attracted towards magnet. So if we try to bring a magnet towards that solution, the iron fillings will start getting attracted to the magnet. Therefore, a magnet can be used to remove iron fillings. So with the help of that, we can remove the iron fillings from the mixture of iron and sulfur. So now next, why there is a need for separation? Now we are studying about that separation should be done, or how we can do separation. But why there is a need for separation? So we will try to understand it now. It is necessary to separate mixture into its components, either to recover useful components or to remove undesirable components. For example, sometimes it is needed that we recover the useful components. We should take out the useful components from the mixture. So that time there is a need for separation, or there is sometimes it is needed that to remove undesirable components. Now sometimes there are certain undesirable components which are present in a mixture, so we need to remove that. So it is very important that we should perform this separation part, or there is a need for separation there. So the first point is the separation of salt from seawater and the recovery of petrol. For we need salt, so there is a need for separation of salt from seawater, and the recovery of petrol, cooking gas and other useful products from crude oil are some examples of how useful products are obtained by separating a mixture into its components. So by using these things, we can recover the useful components. Now the next is the removal of undesirable components. Now the undesirable components. Now these portion was mainly dedicated to the desirable components. Now we recover useful components. That portion now we will try to understand how we remove undesirable components. So the removal of undesirable components, including dust particles and germs from river water, so that we make it drinkable, and the removal of impurities such as pieces of stone and husk from grains to make them edible, are some examples of why we remove undesirable components from a mixture. Now to make the river water drinkable, we have to remove the germs, because with germs and dust particles we can't consume that water. So at that time, undesirable components are needed for needed to be separated from the mixture. So in this portion we will discuss till this part only. In the next video I'll be discussing the methods of separating solid mixtures and the other topics also. So thank you everyone.